Hello students, you are welcome to sirMATHS in our mathematical journey in the world of numbers. Let me still remind you that it is good for you to subscribe to sirMATHS and turn on notification to stay updated on our daily discussion in this mathematical adventure, and that is by clicking on the subscribe and bell notification button. You will follow. At today's discussion, which is for grade 10, equivalent to SS1, is word problem. Word problem. And that is leading to simultaneous linear equations. Word problem is what we are going to discuss. Remember, previously we discussed this simultaneous equation and discussed the methods of solving problem on simultaneous equation. That was elimination, substitution. Graph is one of them. We did not treat that graph. But let us first of all look at word problem that leads to this very simultaneous linear equation and use any of these methods to solve each of them. Let us take this very question where we are told to divide $75 into two parts. And we are told so that one part is 2/3 of the other. Remember, word problem has no formula. You follow it word by word, sentence by sentence, until you have transcribed the sentences into arithmetic symbol. That is the essence of word problem. To enable you to acquire the ability of translating sentences into arithmetic symbols. We expected to divide 75 into two parts. We now say, let the two parts be x and y. And that means that x plus y is equal to 75. This is our equation 1. And we are told that one part is 2/3 of the other. We can say that x is equal to 2/3y, equation 2. We have derived the equation, and so we can solve by whatever method, either by elimination or by substitution. But I will encourage you to use substitution because already we are given the tentative value of x. And since we have the tentative value of x from equation 2, we now replace or substitute this value for x in equation 1. What do I mean by that? We now substitute two over 3y for x in equation 1. Remember, we derived this from equation 2. We shouldn't substitute this in the same equation 2 as we discussed previously. Since this is derived from equation 2, we now substitute in equation 1. And what does it mean? In equation 1, anywhere we see x, instead of writing x, we write 2 over 3y. And so we now we go on by saying this is x, which is 2y over 3 plus y equals to 75. Equals to 75. So we go on. What do we do here? We can make this one fraction. We can make this one fraction, and that is by saying the LCM is 3, and the LCM is 3. 3 divided by 3 is 1. 1 times 2y is 2y. By implication, this is 1. So 3 divided by 1 is 3. 3 times y is 3y. So we now have 2y plus 3y is 5y over 3 equals to 75 over 1. We now cross multiply, and that will give us that 5y is equals to 3 times 75. How do I get 5y? 5y times 1 will give us 5y. And then 3 times 75. Let us go up. We now have 5y divided by 5. What you do to the left, you do it to the right. 3 times 5 is 15. Carry 1. 3 times 7, 21 plus 1, 22. Divided by 5. So y is equals to 22 divided by 5 will give us 4. Remaining 2. 25 divided by 5 is 5. So this is our y. Therefore, x, which is 2 over 3 times y, and y is 45. This will give us 3 here, 1, 3 here, 1, remainder 1, 3 to 15, 5. We have 2 times 15, and that will give us 30. We summarize by saying x is equals to 30 and y equals to what? That is 45. We have solved. 1, we have translated the sentences into arithmetic symbol and use substitution method to solve the simultaneous linear equation. I hope that is clear. Let us still have one question to this effect. A woman's age and her son add up to 45 years. A woman's age and her son add up "45 years. 5 years ago, the mother was 6 times the age of the son. 6 times as old as the sun. We expected to find how old was the woman when the son was born. Yes, a woman's age and her son out to 45 years. And 5 years ago, the woman was 6 times as old as her son. How old was the woman when the son was born? We now derive 2 linear equations from this, and then solve by whatever method you so wish. To do that, we now say, let the son's age the X and the woman Y. We go on to solve. So we now have X plus Y is equal to 45, and that is equation 1. We're told that they add up to 45 years. And then 6 years ago, the son will be X minus 6, and the mother will be Y minus 6. 6 years ago. Okay, permit me to make is 5 years ago, according to the question. Now, the woman that 5 years ago, she was Y minus 5. That 5 years ago. And by this time, she was 6 times X minus 5. Let's take it again. The age of the son and the mother sum up to 45 years. And we have said let the son be X and let the mother be Y. So X plus Y is 45. And we are told that 5 years ago, the son was X minus 5 old, and the mother was Y minus 5 old. And the question told us that at this time, 5 years ago, the mother was 6 times the age of the son. So the age of the mother 5 years ago was 6 times the age of the son. And so we now say Y minus 5 is equal to 6X minus 30. We open the bracket. Then we collect as usual. This is 6X minus Y. We are collecting like terms. This is going over here. So the positive Y crossing becomes negative Y equals to minus 30 plus 5. Let's take it again. Okay, this cross, okay. This 6X, the Y met it here. And then this is minus 5y, I will explain better, plus 30. Now this is the 6x. We are collecting like terms. Remember, in a linear equation, all the variable will be one side and the constant the other side. This y crossed, and as it crossing, it was positive here, it has to be negative. And this 30 will cross. Remember, it was positive, negative, crossing it to become positive. So we have for equation 2, 6x minus y equals to 25. How do we get the 25? 30 minus 5. This is our equation 2. So we now collect the two equations and solve by whatever method we so wish. I still expect us, we can use substitution in this, because I told you it's always wise and simpler to use substitution when one of the variable, the coefficient, is unit, that is 1. Here we have this is 1, this is 1, this is 1. We can use substitution by saying from equation 1, x is equal to 45 minus y. From equation 1, x is 45, the positive y crossing becomes negative y. And then we substitute. (45 minus y) for x in equation 1. Okay, we derive from equation 1 this time around, we substitute in equation 2. Now, which means in equation 2, anywhere we see x, instead of writing x, we write 45 minus y. Let's go up. There is an error here. Let's make a correction here. Remember, we have x equals to 45 minus y, and we are now substitute 45 minus y for s in equation 2. Here is equation 2, which is 6x. This is 6, and this is the x minus y, not plus y, equals to 25, not 45. And so we multiply 6 by 45, it gave us 270. And 6 times minus y is minus 6y, minus y equals to 25. Collecting like terms, we have minus 7y equals to 25 minus 270, which is minus 7y equals to 10 minus 5 is 5. This remains 6. 6 minus 2 is 4, and this remains 2. So minus 7, this is minus, remember? Because what we are subtracting is bigger than what we are subtracting from. Minus 7y divided by minus 7 is equal to minus 245 divided by minus 7. Minus 7 cancel minus, so y is equal to negative, cancel negative. 7 here, 1, 7 here, 3, for 21. Remainder 3. 35 divided by 7 is 5. So we now have y equals to 35. I take it again. 24 divided by 7 will give us 3. You know that 7 times 3 is 21. So 24 minus 21 will give us 3. Then 35 divided by 7 will give us 5. So y is 35. Therefore, x is equals to, remember we say x equals to 45 minus y, and y is 35. So the sum 5 minus 5 is 0, 4 minus 3 is 1. The sum is 10 years, while the mother is 35 years. But the question says, how old was the mother when the son was born? So she was 35 minus 10 which is 25 years. That is her age when her son was born. We have solved that word problem. Please make the correction. That is for that. Let us look still at word problem in a diagram. Word problem in a diagram. Let's have this very question. Let this be equilateral triangle. In the equilateral triangle, the three sides are equal, you remember? And let's have these values. This is 4a, and this is 3b, while this is a plus b plus 3. And the question we ask to find the length of the sides given. Find the length. We are finding the length of this very size of this equilateral triangle. Find the length of the side. Remember, the three sides of equilateral triangle are equal. Each of them is equal. In other words, 4a is equal to 3b equals to a plus b plus 3. Now we need two equations, two linear equations. We can have one, 4a is equal to a plus b plus 3. We marry these two sides to form one equation. That will give us 4a minus a, this a crossing, minus b, the b crossing, equals to 3. And that will boil down to 3a minus b equals to 3. This is our equation 1. We can as well have a plus b plus 3 equals to 3b. So we collect like terms, all the variable in one side and constant to the other side. We have a plus b minus 3b equals to minus 3. And that will give us a minus 2b equals to minus 3, equation 2. A plus b minus 3b equals to minus 3. The positive 3 crossing becomes negative 3. So we have derived our two equations. We solve by whatever method. 3a, we are collecting what we have, minus b equals to 3. And we have a minus 2b equals to minus 3. This is our equation 1. This is our equation 2. By what we have, we can say from equation 2, a is equals to the negative 2b crossing becomes positive 2b minus 3. We have found the tentative value for a. We now substitute this value. Substitute. (2b minus 3) for a in equation 1. We derived that from equation 2. I have to substitute in equation 1. In equation 1, we have 3a, and a is already 2b minus 3. This minus b equals to 3. We open the bracket. This is 6b minus 9 minus b equals to 3. We collect like terms. This is 6b minus b equals to 3 plus 9, and that is 5b equals to 12. I hope we all are following. We picked from what we have, and now this is what is resulting. Therefore, 5b divided by 5 equals to 12 divided by 5. And so 5 cancel 5b will give us 2 whole number 2 over 5. Therefore, a is equals to, we say that a is equals to 2b minus 3. 12 over 5 minus 3. That will give us 24 over 5 minus 3. Boiling down to, this will give us 4 whole number, 4 over 5 minus 3. I hope you are still seeing what I'm writing. Or do we go up to conclude it? And that 4 whole number, 4 over 3 minus 3. That will give us 1 whole number, 4 over 5. So a is equals to 1 whole number, 4 over 5, and b is equals to 2 whole number, 2 over 5. And so we end up our discussion on this. Thank you very much for listening. Again, don't fail to subscribe. Thank you.